Hi, my name is Blair Johnson, and in this presentation we're going to be discussing the beginner roadmap to Edge Computer Vision. By the end of this, if you're a complete newcomer to computer vision and doing computer vision locally and deploying devices that are doing computer vision, my hope is that you have some sense of the general pipeline from beginning to end of an Edge computer vision project, and you'll have some idea of the tools and resources that are available to you and where to go to learn more about how to actually implement one of these systems. So why Edge computer vision? Well, computer vision can solve many useful tasks, and so one of the most powerful aspects, really the defining aspect of Edge computer vision, is the ability to take some computer vision model and deploy it out in the real world. So say the example we're looking at right here is we have Johnny, who's noticed these new electric scooters are popping up all over his neighborhood, and he doesn't like that they're blocking the sidewalk and that users are riding on them really fast and colliding with pedestrians and all these things. And he thinks maybe there's a way he could build a device that regulates the behavior of these and limits what they're able to do. So this would be an excellent example of where you want to a situation where you may want to use Edge computer vision to actually deploy some computer vision technique locally on a device that isn't networked. So when you're starting out with computer vision, you need to understand what the task you're trying to solve is. These are broadly the three simplest and arguably most common computer vision tasks. On the left, we have object detection, which identifies the locations of different objects within an image and then often also tries to classify and tell you what they are. Then we have segmentation that tries to identify the specific pixels within the image and what type of or class of object each pixel belongs to. And then finally classification, which is the bare bones, most simple rudimentary case of computer vision where you just show a model a picture of some object and it tells you what that object is. And you want to know the hardware you're going to be operating on. If you're training a model yourself or often doing inference with very large models, you're going to need big, expensive, power-hungry hardware, and this costs a lot of money. But one of the cool things about Edge computer vision is you can often get away with using very low-power hardware because you're using very efficient models in order to deploy them out in the real world and run with low latency. So we're going to quickly go through a couple options. The Raspberry Pi is an awesome beginner option. It is surprisingly capable and very cheap. The NVIDIA Jetson Nano is a very capable board. It actually has an onboard GPU, which will accelerate a lot of the operations involved in a computer vision model, and it starts at $99. The Coral Dev board is a board that has a specialized piece of hardware specifically designed for running neural network operations, which is really, really cool. And it means you can get very efficient throughput for a fairly low power consumption, especially compared to other options. Again, this starts at $99. Then you have the USB accelerator. This is a great way to augment the capabilities of a different device. The USB accelerator could be plugged into something like a Raspberry Pi to just provide that accelerator capability to a device that does not have one natively, like the Pi, and it comes at a lower cost. Here's another cool board called the Luxonis Oak D. This starts at $200 and has an onboard Intel Movidius X vision processing unit. This board also has some other cool features. It has a 4K 60Hz camera and two stereoscopic depth cameras that run at 120 Hz with a global frame shutter. This is a very specialized board and you can do a lot of cool things with it. There's also another class of boards that are just starting to appear that are really, really small and low power. So this is the Cyped MAI-X board. This is the dock version. It starts at only $20 and it has a onboard K210 KPU that runs neural network operations very efficiently. These types of really low power boards offer a lot of promise, and I look forward to seeing what people make with them in the future. So you have a board, you have something you're going to run your system on. Now you need to understand what you're actually going to use and what you're going to deploy. So it's time to look for models. the easiest way to start a project is to look and see if anyone's done what you're looking to do before. Often there are pre-trained models available on the internet that you can simply repurpose for your specific use case. Great places to find those are the TensorFlow Hub and this website called ModelZoo. You can browse around and sort by the type of task that you want your model to solve and look at existing models and go try to find information about how they perform. Keep it small. If you're trying to deploy something on an edge computer vision board, especially something low power like a Pi, you're going to want to use very efficient model architectures. These are some great ones to start with: MobileNet, TinyNet, EfficientNet, or make your own. Lots of really, really simple tasks can be solved by very simple neural network architectures, and just a day or two of YouTube tutorials is really all you need to start making your own models and playing around and finding something that works well for you. Understand your framework. If you're going to be training a neural network or deploying a neural network, you need to start to understand the different APIs and frameworks that people use for deploying. Often, if you have a pre-trained model, the process of deploying is really easy, but you're still going to have to know which framework your model uses in order to go look up information about how to actually deploy it. These are some common ones: TensorFlow, Keras, Caffe, PyTorch, OpenVINO, and ONNX. Some of these you can use for training and inference, some are just inference, but all of them are relatively simple to use. As a beginner, there's lots of information and great resources available online. So what if you can't find a model that does exactly what you want? Well, another great option, in addition to training from scratch, is transfer learning. Transfer learning essentially takes a model that was trained for one task and repurposes or fine-tunes it on a different task. This greatly reduces the amount of data that you're going to have to collect if you want to solve some new task of your own, and it's an excellent option. I'd highly recommend this over training from scratch unless you absolutely have to go out and collect raw data for training completely from scratch. So say you do need to train from scratch. You can't find anything available on the internet that you can repurpose for what you want to do. How do you actually do that? Well, first, I double check that what you're looking for isn't on the internet. There's lots of great stuff out there. Kaggle's a great resource, and just Google around for what you're trying to find. But if you absolutely have to, you can collect your own. This image on the right is an example of some images from a sidewalk classification data set, which would be useful in the case of Johnny, who's trying to identify if scooters are riding on the sidewalk or in the street. If you're going to collect your own data, a great way to do it is find some way to automate it. If you're Johnny and you're trying to identify sidewalks and roads, it's going to be useful to make a little device, maybe a script on your Raspberry Pi, that will just record video frames and then strap it to the front of a scooter the way you might deploy your actual device and go right around town and collect data. As you collect your data, be cognizant of how you plan to use it. You need to make sure that you're getting all of the features that your model is going to need to make the accurate classification, in the case of classification. Here you can see Johnny cares about sidewalks and roads, so he needs to make sure that he has a clear view of the sidewalk and the road. And during training, he's probably going to crop down to just that area so that the model is not confused by any extraneous information. Use free resources. You don't have to have a big, powerful computer to train models these days. Kaggle and Google Colab both offer free compute resources and very high performance compute resources that are available to anyone with a free account. Definitely check out those options. Then go deploy your model. Use a framework like TensorFlow Lite or OpenVINO or ONNX. All of these offer really fast and efficient, low power inference on pre-trained models. That's an excellent way to take a low power device like a Pi and deploy a really high performance model on it. Additionally, over here on the right, this is what the general pipeline for a computer vision application is going to look like. You're going to get camera input, often with a library like OpenCV using C++ or Python, and then you're going to crop and normalize your information, extract just the region of the image that you need for your model, pass that into your inference engine, probably TensorFlow Lite, OpenVINO, or something using ONNX, and then you're going to get results out on the other side, and it's up to you to do something with those. Maybe call an API that ends a user's ride or something like that. And that's it. You've just learned essentially the entire process from start to finish. You have some sense of the steps that you need and the tools that are out there, and I hope to have inspired someone to go out and make a computer vision project. Thank you.